Lesson 2-5, Irrational Numbers. So in this video, we're going to review what our irrational number is and then determine if numbers are rational or irrational, and then find approximate value of irrational numbers. So first off, what's an irrational number? Well, irrational numbers are radicals or decimals that never end, they never repeat, and they cannot be written as a fraction. So in this picture, you can see the difference between rational numbers and irrational numbers. And over here, you see the irrational numbers. You have some radicals here and here and here. You have some decimals that never end, such as Euler's number, and you have pi. Those would be two common numbers you would use in math classes. So, sample problems. Here we identify as rational, irrational. So 6/7 is a fraction, so this can be written as rational. Next, square root of 8, that's a radical, so this is irrational. 0.3, this is repeating, so this is rational. And negative 1.4, since this terminates, this ends, this cannot be irrational, so this is rational. 2.01020304. Now there is a pattern, but it's not repeating, so this keeps going on. That's what the ellipsis at the end means. So this is irrational. Now the next one, we have 0.12122122222, and then because this comes to an end just like that, because there's no ellipsis at the end, this would be rational. But if I were to put the ellipsis at the end, and actually let's make this a little bit different, because I should have put in the ellipsis at the end. So this would be irrational. So it should have been irrational. But the way it stood, it would be rational because I didn't have the ellipsis at the end. It did terminate. But since I just added the ellipsis in there, it would be considered irrational. Next, I have the negative square root of 0.16. Now for this one, if I take my calculator out here and I have the square roots of 0.16, I get 0.4, which is a terminating decimal. So even though it has a radical, this would be like a perfect square. So we would consider this one to be rational. And then the next one, we have 2.8 divided by 0.13. Now I can do the division, and it's written in fraction format. So for this one, it would be rational. And a few others, I have 0 divided by the square root of 7, and 0 divided by the square root of 7. Anything with a numerator of 0 is going to be equal to 0, which would make this rational. And we have the negative square root of 4.9. That is a perfect square. So that would give us, and just to prove that, so if I did the square roots of 4.9, actually no, that would be irrational. Sorry, if it was 0.49, then it would be rational, but because it's 4.9, this would be irrational. Next, I have 9.5432 with the 5432 being repeated, so this is rational. Next, negative 1.4, since that's a terminating decimal, this is rational. Here I have a long decimal with the ellipsis at the end. That means it continues going on forever. There's nothing repeating. So this is irrational. This one has pi in it, which is an irrational number. Here I have 4/9 is a fraction, but they are inside of a radical, but they are perfect squares, so this would be rational because it would equal 2/3. Next one, it's in a fraction format, but because I have a radical in the numerator and a radical in the denominator, this would be considered irrational. Now, if the square root of 6 and square root of 12 was a perfect square, then it would be considered rational. But this one is irrational. The next part, we're going to find rational approximate value to the given place, and we're going to use a calculator for this. So grab our calculators here. We're going to do pi, and we're going to divide that by 4. And we're going to round it to the nearest thousandth. So that's 3 decimal places. So that would be 0.785. So 0.785. Next, we have the negative square roots of 45. And that's going to give us a negative, and we have to round to the nearest tenth. So that would be negative 6.7. And the last one here on this slide, we have the square root of 297. And we have to round to the nearest hundredth. That's 2 decimal places, so that would be 17.23. And our last ones, we're going to find a rational and an irrational number between the given values. So a rational number could be a fraction between, or it could be a terminating decimal. I'm going to do 10.5. because that's a terminating decimal. And if I were to do an irrational number in between, I could do the square root of 10.5. Next, I have 3 and then 3.5. So a decimal between that would be 3.25. That's a terminating decimal, and then that's rational. And then I could also do the square root of 3.25 as the irrational number. So that is our lesson on irrational numbers.